Hello, and welcome to this webinar presented by Bio-Rad Technical Support on using the BioPlex Manager and DataPro software to streamline multiplex analysis. My name is Maribeth Wirt, and I'm a Senior Technical Support Consultant for Bio-Rad. One of my specialty areas is the BioPlex and MagPix instruments and their software. I hope you will find this webinar informative. Before we get started, I'd like to cover a couple of housekeeping items. First, everyone's microphone has been muted to reduce background noise. Second, if you have questions at any time, please enter them into the Q&A box on your screen, and I'll answer them at the end of the webinar. So what is BioPlex Manager software? It is the analysis software for all of Bio-Rad's bead-based multiplexing instruments, the MagPix, BioPlex 3D, and the BioPlex 100 and 200. Data from the MagPix and BioPlex 3D are collected using BioPlex Manager MP or Exponent software and then exported to BioPlex Manager for analysis. The BioPlex 100 and 200 systems use BioPlex Manager to both collect and analyze the data. To ensure the most accurate results from analysis in BioPlex Manager, you will need to take several steps to assess the standard curve quality and optimize the standard curves before analyzing your data. Assessing the standard curve quality includes optimizing the standard curve by using the Optimize Standard Curve feature in BioPlex Manager software, using the recovery range to set the standard curve limits, and using 5PL regression for the best curve fit. Analyzing your data should include customizing the data view in the report table and standard curve graph, looking at the quantitation in the report table, including the use of dilutions, replicates, %CV, and out-of-range values. Graphing the data, exporting the data into Excel, DataPro, or other software, and doing statistical and multiplate analysis in DataPro software. Before going into the details of assessing standard curve quality, I want to review some of the terms I'll be using to discuss the standard curves. Understanding these is essential for correctly evaluating your standard curve data. First are the upper limit of quantitation, the lower limit of quantitation, and the limit of detection. These set the limits for the detection and accurate quantitation of your analytes. The upper limit of quantitation, or ULOQ, is the highest standard point in the standard curve where the standard replicate values have an intra-assay %CV of less than 20%, and the recovery value is within the recovery range set in the protocol, usually between 70 and 130%. The lower limit of quantitation, or LLOQ, is the lowest standard point on the standard curve that fits the same criteria as the upper limit of quantitation. Together, these set the highest and lowest points on a standard curve between which the data can be accurately quantitated. As we will see later, the fluorescent intensity values representing the upper and lower limits of quantitation are indicated by lines across the standard curve graphs. The limit of detection is a measure of the assay sensitivity, although it is not the same as the lower limit of quantitation. The limit of detection is the lowest point at which the fluorescent intensity can be distinguished from background. It is calculated from the blank's mean fluorescent intensity plus 2 standard deviations. Values below the lower limit of quantitation but above the limit of detection can be calculated but may not be accurate. Whether or not the quantitation between the limit of detection and lower limit of quantitation should be used is a judgment call, although we do not recommend using it since the accuracy is lower than the data between the upper and lower limits of quantitation. Next are the recovery range and working range. These determine the limits for the range of concentrations that can be calculated in the assay. The recovery range is the primary measure we use for assessing standard curve quality, since it compares the fit of the standard curve to the actual standard data. A good standard curve should have all points fall within the recovery range set on the standards information window of the protocol. The default range is 70 to 130%, but please check the specifications of the assay you are running to determine whether a different range is needed. The recovery percentage for each analyte standard concentration is determined by first back calculating an observed concentration from the standard curve. This is then divided by the expected concentration and multiplied by 100 to give a recovery percentage. Mathematically, this is expressed as the observed concentration divided by the expected concentration times 100. These values should fall within the expected recovery range for your assay. The working range is the concentration range that can be precisely and accurately measured by an assay. It is bounded by the lower and upper limits of quantitation. Finally, I'd like to go over the regression analysis used to fit the standard curves in BioPlex Manager. BioPlex Manager uses an algorithm called Brendan's 5-parameter logistic curve, or 5PL regression, to derive the best fit for the standard curves. This fit requires at least 6 standard values to calculate. One difference between the 5PL regression and the more common linear regression is that 5PL regression doesn't have a single value, like the R-squared value in linear regression, to determine the standard curve quality. Instead, each standard curve calculates 2 different measures of the goodness of fit, the residual variance, and the fit probability, described here. To be clear, neither of these is an absolute measure of goodness and fit and should be considered secondary guidelines only. Instead, you should use the recovery range as the primary assessment of the standard curve quality. For more details on the mathematics of the 5PL regression, please see Bulletin 3022, Fitting Brendan's 5-parameter logistic curve, on our website at www.biorad.com. So let's see what happens when we apply these parameters to actual data. For this demonstration, I'll be using a data file generated by Bio-Rad's R&D department. The data were generated with the Human Cancer Biomarker Panel 1 using serum from male and female patients with or without various types of cancer. When you open a data file, it opens to the report table with a default view of the average fluorescent intensity for the sample replicates, the standard deviation, and the percent CV for the replicates, the concentration and range, and the observed concentration. The standards have additional columns for the expected concentration and the recovery percentage. The buttons in the left panel take you directly to view the raw data collected by the instrument, the report table, the standard curve graphs, or graphs of the data. In each section, the BioPlex Manager software gives you many options to customize a view that is most useful to you. First, we'll look at the report table options. Access to the viewing options are located in the row of icons above the table, or they can be accessed from the Table Options and Report menu in the Report Table Options window. Starting from the left, you can check the information from your protocol, notes, feed regions, the plate setup, and information on the standards, controls, and unknown samples. Other icons will let you view outliers, view replicate, organize the table by data type or group, and switch between viewing the data for a single analyte or viewing all analytes on a single page. If you are viewing the data in single analyte format, you can switch among the analytes by using the drop-down menu. Once the data view is set, we can start analyzing the standard curve data. In this example, we'll look at follistatin. You can see that there is an 8-point standard curve set up in duplicate, with the table showing the fluorescent intensity for each individual replicate, as well as the average for all the replicates. In general, the percent CV should be less than 10%, but this may be higher for some individual assays or sample types. For Bio-Rad assays, you can check the product information sheet for the expected inter- and intra-assay percent CV values. The next two columns show the concentration in range and the observed concentration. The observed concentration is the concentration calculated from the standard curve. The concentration in range is the concentration calculated between the upper and lower limits of quantitation, the working assay range, and provides a quick check on which samples can be accurately quantitated. It is typically the same as the observed concentration, but we'll look at an example where they differ shortly. The expected concentration is the concentration expected based on the standard concentrations entered into the protocol. This is used with the observed concentration to calculate the recovery percentage. Remember, the recovery is the observed concentration divided by the expected concentration and then multiplied by 100 to give a percentage, and that is shown here in this column. When you examine the standard curve data, you should first check the recovery values. These should fall within the range you set for the assay. Again, the default is 70 to 130%. Although the closer the values are to 100%, the better the fit will be. For follistatin, you can see the recovery values are all close to 100%, so the standard curve will be a good fit for the data. If your samples are diluted, the last column will show the dilution factor entered into the sample information section of the protocol. As long as the dilution is recorded, the BioPlex Manager software will take a dilution into account when calculating the observed concentrations, so the concentration given will be that of an undiluted sample. In contrast, let's look at basic fibroblast growth factor to see how this analysis applies to a standard curve where not all points have a good recovery percentage. Here you can see that both the S1 and S8 standard points have recovery values outside the expected recovery range. In the column concentration in range, both are marked as out of range, or OOR, because the concentrations do not fall between the upper and lower limits of quantitation, meaning they cannot be accurately quantitated, even though a calculated observed concentration is shown. Removing these points doesn't affect the sample quantitation, but does improve the overall curve fit. Since there are still 6 good standard curve values for basic FGF, the BioPlex Manager software can use 5PL regression for the standard curve fit. As I'll be showing, you can use the optimize function in the standard curve graph to do the optimization for you. Since the S1 and S8 standard curve points have poor recovery values, they will be marked as outliers. There are ways to do this manually if needed. To access the standard curve graph, click on the standard curve button in the left pane. Now see what the standard curve graph actually looks like, and in this case, how not all the standard points actually fall on the standard curve trace. To optimize the standard curve, we can use the Optimize Standard Curve feature here in the left panel. The Optimize Standard Curve feature automates optimization by applying a set of algorithms to remove outliers and optimize the recovery values for the standard curve. You can use it to optimize just the standard curve you are viewing, or if you check the Apply Across All Analytes box, it will optimize the standard curves for all of the targets in your assay. If you also choose to view the report after optimization, it will detail which standard curves were optimized and what specifically was done to optimize them. Here we'll click the Optimize button, and you can see it run through optimizing each standard curve. The report shows that most of the standard curves required no further optimization, but basic FGF did have more than one standard point removed and marked as an outlier. This is noted on the graph where the points have changed to open boxes with an X in them to indicate all the replicates were deleted. You can also see that the upper limit of quantitation and lower limit of quantitation are indicated by these lines across the graph. The number in parenthesis next to each point is the recovery percentage. The Labels drop-down menu lets you change what is viewed in the label. For example, we can choose to view the observed concentration instead. Next to the drop-down menu is one that lets you view the error bars on each standard curve point. The green and yellow triangles on the standard curve graph indicate the concentrations for the unknowns and controls. Again, you can use this as a quick check on whether the sample values fall within the assay working range. If you do not want to see these, you can simply uncheck the boxes for showing the control samples and showing the unknown samples. To view the standard curve for a different analyte, simply select it from the drop-down menu. Any changes made to the standard curve graph are automatically updated in the data displayed in the report table. As I said earlier, the default regression type for BioPlex Manager standard curves is 5PL, since it provides the best fit for the standard data. If you do not want to or cannot use the 5PL regression, there are other options which you can select from this drop-down menu. The only time you would want to use a different regression type is if you have fewer than 6 points on your standard curve for the 5PL regression. Underneath the graph, you can see the 5PL equation that was used to plot the standard curve, along with the fit probability and residual variance values for the curve. Please remember that the fit probability and residual variance are not absolute measures of fit and should not be used to determine standard curve quality. The recovery values are a much more accurate assessment. Once you have optimized your standard curves, you can visualize the data using BioPlex Manager's built-in graphing functions or export the data for graphing in another program. To use the built-in graphing features, click on the Graphs button in the left pane. Here you can choose to view all the unknowns and controls, or all samples. And the default value on the y-axis is the fluorescence intensity, although you can choose to change that to a different parameter using the Results drop-down menu. For example, here we'll view the concentration in range. To view the data for a different analyte, just select it from the drop-down menu, or use the green arrows to scroll through the various analytes. You can customize the graph using the icons at the top of the window. Graph Options icon lets you change the view to single or multiple analyte groups with single or multiple samples, choose 2D or 3D columns, and whether you want the error bars shown. Using the Add Graph icon lets you create a custom graph by adding selected analytes to a particular graph, which is useful if you only want to compare a subset of your samples. The Edit Graph Data button lets you edit a custom graph if you have one previously saved. The next two buttons let you export the data into Excel or BioPlex Data Pro software for further graphing and analysis. Before exporting the data, you need to set the parameters for how you would like the data exported. These options will vary slightly depending on if you're exporting the report table, standard curve, or graphs. To export the report table, select it, then go to the File menu and select Document Export Properties. Here you can select the output format, BioPlex XML, is a comprehensive export that is useful for exporting data to LIMS systems. Output CSV format is for export to Excel, or you can use a custom style sheet. After setting the export properties, go to the File menu and select Export Table. Choose the single analyte layout if you want each analyte to have its own sheet, or multiple analyte layout if you want all the data from all the wells on a single sheet. Selecting 96 well plate shows the data in the 96 well format of the assay plate. Click on Advanced Export Options to select which columns to export, the export source, and the destination. Once these are set, click OK to export the data. Alternatively, you can export the data into the BioPlex Data Pro software for multi-plate or statistical analysis. Data Pro also allows you to evaluate your biological replicates. Click on the Export to Data Pro button and name the file. When the file opens in Data Pro, you can add it to a current project or create a new project. Here we'll create a new project. We'll provide it with a name and enter who the owner of the data is. You'll also want to select the sample types to be included in the analysis, which will typically be the unknown. If you later need to add sample types not included here, you can do that from within the software. Once you have imported the data, you can use the 4 buttons on the left panel to walk through doing your analysis. The first step is to manage your data sets. You can import additional data files. As I said, you can change the sample types to be included in the analysis. You can change the order the analytes are listed in, or you can merge samples from different plates or panels. The bottom window shows you the standard curve for the selected analyte, which you can change by selecting a different one from the drop-down menu. If you're analyzing multiple plates, you will see each plate standard curve overlaid. Next, click on the Edit Samples, Add Columns button. Now your sample information is listed in columns, which will let you sort the data based on the dataset, sample type, description, well locations, or sample label. Customize Sample Table option lets you change the order of the columns or add custom columns for specific assay parameters, such as drug concentration or assay time. You can also add columns by using the Add Column menu above the table. Any parameters you plan to filter for in the next view can be added here. You can also click in any well to add information or update it. Once you have set your samples and columns, you can click on the View Results, View Heat Map button. The default option gives you the results from a single analyte, or you can view the data in a multi-analyte layout with all the results on a single page, or you can view it as a heat map. In the single and multi-analyte layouts, you can use the buttons above the table to select additional parameters to view, such as the standard deviation values. On the heat map, you can select the parameters being mapped, how they are displayed, and what color palette is used on the heat map. After you have viewed the results, you can use the Perform Analysis, Create Charts button to perform statistical analysis on your data and graph the results. To set up your statistical analysis, first select the samples the test will be performed on. In this example, we'll use the description. You can see how the charts and table update as you select different parameters. If you have a control for your assay and your analysis, please select that as well. Next, the DataPro software chooses a statistical model based on the dataset, but you can change this. If your data are normally distributed, use the t-test or one-way analysis of variance. If the data aren't normally distributed or you're not sure, use the Mann-Whitney-Kruskal-Wallis test. Finally, select how you want the data filtered for viewing. Once the test has been run, you can see that the table has updated with the results from the statistical analysis. There is now a p-value for the statistical test, the fold change relative to the control, and the average and standard deviation values. You can see that the graph below the table shows the data plots and p-values for each group. The square in the legends box indicates which analyte is being displayed. You can change the y-axis values by clicking on one of the buttons above the table. You can also choose to view the results for multiple analytes at once by using the Analytes drop-down menu and clicking on the additional ones you wish to view. And while the default graph type is a scatter plot, you can also view it as a box and whiskers or a bar graph by clicking on the appropriate button. To save the analysis set, you can use the Save and Save As buttons at the bottom of the analysis box. To export the graphs, you can right-click and either export to various formats or copy and paste the graph into another presentation. You can also export the data into another statistical package by clicking on the Export to Statistics Software button. These export options will help eliminate the worry for copy and paste errors. As you can see, the BioPlex DataPro software provides many options for analyzing your data, and I hope you can see the potential in the software. In this webinar, we covered how to assess the standard curve quality by using the recovery range to set quality standard curves that you can trust for your sample quantitation. We discussed using the Optimize feature in the BioPlex Manager software to set outliers and optimize the standard curve. We also discussed using 5PL regression for the best curve fit. We also discussed how to analyze the data by customizing the data view in the report table, evaluating the quantitation in the report table and standard curve, graphing the data, exporting the data to Excel or BioPlex DataPro software for further analysis, and using the DataPro software for multiplate and statistical analysis of your data. Thank you for attending this webinar on doing data analysis using the BioPlex Manager and DataPro software. If you have any questions, please feel free to contact technical support at 1-800-424-6723, option 2, or email us at support@biorad.com.